repeat that again, please?
Got some housekeeping things I want to do really quickly. All right, so, and then we'll get into the meat and potatoes of all the stuff we got to do today. All right, so first things first, I hate clever. Okay, sorry, I hate Canvas. Canvas and I are not friends. And I'm sure that all of you love Canvas, but for me and some of the people that I work with, it is just not fun at all. And of course, my camera is being really a whole lot of fun today. Hello, zoom in. Hi. My camera is really, oh, come on now. Okay. Yeah. All right. So now, things that I want to talk about today. Today you have a quiz. Yay. Now,
the camera's out of focus.
I'm gonna hold on for just a second. I'm gonna see if I can fix this thing real quick. So in order to do this quiz, by the way, this quiz is really not that bad. We're gonna go over everything in it today during class. You're gonna be fine and ready to rock and roll. No big deal. But time out. I think Mr. Jones, when he gave you a quiz, like you would take pictures of all of your work and then you would upload those in Canvas. Is that right?
No, we'd email them.
Is that a yes or a no?
No.
So how did you take quizzes with him?
We emailed the work.
He'd give it to us in Canvas, and depending on whether or not he wanted us to work it, after we did it, we take a picture of it and then we send it to him.
Okay. You know what? Let's do that, because that's what I do in my other two classes that I look at homework in. Okay. So here's the deal. Quiz today. Here's what I will do. I'm just going to take that out. Stop that. All right. So I will post the quiz on an announcement. And I'll do that at the end of class. And I need your pictures, and they need to be readable. All right. Don't send me an icon, right? That would suck. Take pictures and send them via email. Due by midnight. Today. Okay. Now. Okay, that I think we can do. Cool. Are we all cool on that? Can I get thumbs up that we all know what's going on today? All right. Beautiful. Good enough. All right. Okay. So let's make sure that everybody's ready to rock and roll for this quiz today. Okay, so I'm basically gonna walk you through. If you take notes on this stuff right now, you're gonna do fine. All right, so, okay. Oh, thank you, good call. What's my email? Okay. So roncoca@pwcs.edu. Okay. Everybody cool? Wonderful. Unica, you came in late. There's a quiz. I'm going to post it at the end of class. Take pictures of your work. Submit it by midnight. That's my email. All right. Let's do this. So you got to be able to add and subtract. I'm just going to list everything up. You got to add and subtract polynomials. Okay. Do we know how to add and subtract polynomials? Do you want to do one or two? Great. Let's do one or two. All right. So I've got x cubed plus 2x minus 4 plus 5x squared minus 8x minus 3. All right. Now, since I'm dealing with addition, I don't need to worry about distribution. I can just drop the parentheses and combine my terms. So x to the third plus 2x minus 4 plus 5x squared minus 8x minus 3. Now, I want to have my answer in standard form. So I'm going to look for my biggest exponent, which is my x cubed. So that's going to be my very first term because it's got the highest exponent. Then I look for the next highest exponent, which is x squared. And there's only one of them too. So that one, it goes there. Now, the next highest exponent is x to the first. And I've got both of them right here. So I have to combine these like terms. And I get negative 6x. 2 minus 8 is negative 6. And now my last are my constants. So I combine the negative 4 and the negative 3. And I get negative 7. Do me a favor, please, people. For the love of God, please put a box around your answers. Because some of your work looks like you're doing the math with your feet. Okay, I've seen some of your handwriting. All right. Okay. So please box your answers. Okay. Now let's do another one. Let's do, you know what? We'll just do the same. We'll do a very similar kind of problem, but this time with a minus. That's an 8. X minus 3. So since I've got a minus, I have to distribute the negative sign to everybody. So x to the third plus 2x minus 4 minus 5x squared plus 8x plus 3. Now I can combine my like terms and put it in standard form like we did before. So just like in the last problem, we go with the highest exponent, which is x to the third. My next highest exponent is now negative 5x squared. 2x and 8x get combined because those are the first power. So that's 10x. And negative 4 plus 3 is negative 1. And so this is that answer. All right. Happy, happy, wonderful. All right. Now, I think that probably is okay with most people, I would imagine. All right. So the next you're going to have to write, next thing you're going to have to do is factor polynomials. All right. So let's first do 5x squared plus 30x minus 80. Now, before we start stuffing rabbits into things, we pull out a GCD. Always, always, always pull out a GCD. Okay, that's critical. And my GCD here, the one thing that everybody's got is a 5.
She's gonna come out here as soon as she hears her what?
But excuse me, brain damage. Where's my erase? Close enough. 16. Okay. And now that I've got it as a monic, now I can break it down like before. 1 and 16, 2 and 8, 4 and 4. Which pair of numbers can make a 6? Somebody unmute and yell it. Thank you so much. So 2 and 8. Larger number gets that symbol. Positive times a negative is a negative. And that would be your answer. Cool. All right. Now let's do one more of those just for giggles. Oh. And hold on. That's where I wrote that. Start over on that one. X to the 5th plus 13, 13. X to the 4th and plus 36 x to the 3rd. So looking at this, okay, my ugly number 3. I can make that 3 look a little better. That is a 3. All right. So in here, what is my GCD?
$13.
Well, I don't have a 13 everywhere. Like I can't divide everybody by 13. But what does everybody have that I could maybe take away from everyone?
X to the 3rd.
X to the what?
3rd.
3rd, right. So now I've got x squared plus 13x to the 1st plus 36. And now we have a polynomial that we can break down. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. All right, and now I'm going to pick the pair that makes 13. That one. So 4 and 9. All right. And the larger number gets that symbol, so it goes to the 9. Positive times a positive is a positive. Okay. So you're going to need to be able to do those. All right. How do we feel about doing that? Scale of 1 to 5. How do you think we're going to be able to do on that? Okay. Give me 1 second. Where is my... Trying to fix something real fast. All right. Okay, now, next thing. All right. What's that thing? All right. So, next thing you're going to be asked to do is to find the zeros and graph or sketch the function. Okay, so here's the deal. You're going to be, it's already going to be factored for you. So if it's already been factored for you, you can find the zeros by just using the zero product property. Okay, you're going to have x minus 2 equals 0 and x plus 1 equals 0. So now your zeros are x equals 2 and x equals -1. Now, this tells me that I've got a multiplicity of 2. Here I have a multiplicity of 1. So if you have your notes from the other day, when you have a multiplicity of 2, gosh, these markers suck. You have a multiplicity of 2, your graph comes up, touches for just a second, and leaves the way it came. Okay, whereas a multiplicity of 1, it goes right through it. Okay, so what you do is you just go to Desmos. Okay, go to Desmos, take a look at it, and you can put it into Desmos just like this. Okay, and it'll give you a graph that will look like this. Now, this point right here will be my x equals -1. And this point that it just barely touches is my x equals 2. All right. But do yourself a favor. You've got Desmos, take it and graph it, but connect, when you do this, connect in your head that it's going to cross at 2 and -1, which you'll see. And the multiplicity, the exponent, tells me how it touches. Does it touch by going through, or does it touch by hitting it and going tangent? Okay, so you'll have 2 of those you'll have to do. Okay, not the end of the universe. Okay, questions, issues, moans, whines, complaints on how to do this. Going once, going twice. Sold to the man in the black box. Now, next thing we're going to do is actually new. but it's really easy. You've actually already done it. You just haven't done it with me, I think. So for a second, I want to just show you how to do this, how to find a polynomial when given zeros. All right. So here's the thing. Before I go into this, if we look at the problem we were just fooling with, okay, let's go back to this for a hot second. I took each pair of parentheses, I set them equal to 0, and solved for x, okay? What you're going to do is you're going to do this exact same thing in reverse. So watch me for a minute. I'm going to tell you that the zeros are 2, 2, and -1. So what that means is x equals 2, x equals 2, x equals -1. Now, do yourself a favor, move everybody over so that you've got a 0 on this side. So now I've got x minus 2 equals 0, x minus 2 equals 0, x plus 1 equals 0. And now, once we've got that, we're going to take these and put them in parentheses. And since these two are the same, that's what you do. And in fact, that is exactly what you did over here. It's the exact same idea. Now, in this case, I broke this up and did it 2 times, okay? But I had to tell you that we had a multiplicity of 2, and that's why it's done 2 times. And that's where the multiplicity of 2 comes in here. So you wouldn't have to necessarily do this identical work 2 times. You just have to remember that you got to make it a multiplicity of 2 when you're done. Okay, so let's do that again. Oh, but wait, I got to do this in standard form, which means I'm not finished with this. I got to take this guy or this guy, whichever, this one's probably easier, and I got to multiply him out. Okay, so you can either do it the way I showed you how to do it, or the way that you learned in Algebra 1, or whatever, but we got to multiply this guy out. So I'm going to take the first 2, or these 2. So 1 and -2, 1 and 1, -2, 1, put a space, -2, 1. So that's what happens when I multiply it out for these 2. So what do I got? I just want to show you what's going on here. I turned this, I did my multiplication, and I turned it into this. Okay. And now I'm going to do that multiplication. And I'm going to run out of room. So I get 4, 2, -2, skip a space, -2, -1, and 1. And now I'm just going to clean that up a little bit. and you're finished. So whether you do like, whether you do your multiplication, like all of this old school stuff, or whether you do it using my method or not, you need to multiply the whole thing out because it's got to be in standard form. Okay, standard form is what I'm looking for. All right, so let's do one more of those. We all done copying? Did you give up on copying? Okay. I mostly got juniors in here, don't I? Cool. So first thing you do is you write it in factored form. And if you've been paying attention, you can probably jump to that right away. You see how I went from those three to these three? Okay. Now I just need to multiply them out one at a time. All right. So using whatever method you like, multiply these binomials together and come up with one final cubic formula in standard form. Do that now, please.
Oh, wait, I don't think I get it.
Say that again. It was really quiet. I couldn't hear you.
I don't think I get it.
Okay, so take these two by themselves and multiply them out. So x times x is x squared. X times 2 is 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is negative 2. Now we have to combine the like terms. Okay, so now we got to multiply it by that guy. Okay, so now you got to do all the distributions and combine all of those like terms. Okay, go ahead and do that and simplify it at the end.
Doesn't matter which two you choose first.
No, it doesn't. Remember, you got the commutative property of multiplication.
Again?
So it'll all come out in the end.
Wait, do what again?
You can do it in any order.
And you or what?
Yeah. If you do it right, it'll come out to be the same answer no matter what.
I don't know what that means.
Okay, so multiply the x times the x, and that's x to the third. And then x to the negative 3 times negative 3 is negative 3x squared. And now we got to do it with the middle one. So
Just repeat that.
yeah, and we just keep, and we do all of our terms. So x times x is x squared. X times negative 3 is negative 3x. And now we got to do it for the last one. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And now we got to combine all of our like terms. So there's only one x cubed. So there it is. These two are both x squared. So we're going to combine them and get negative 2x squared. These two are linear terms. Sorry, x to the first. So I get negative 5x and plus 6. And that's your answer.
Can you do it your method? Let me see something.
Absolutely. Much faster. Okay, so 1, negative 1, 1, 2, negative 2, 2, 0, negative 1, 1. 1, 1, negative 2. Now I'm going to multiply it by this guy. 6, 3, negative 3, negative 2, 1, 1, 1, negative 2, negative 5, and 6. We get the same.
What is that? Wait, hold on, what is that?
I can't hear you. Can you move
What
closer
is
to your
that?
microphone?
What is that?
I can't hear you sometimes. Could you move closer to your microphone? You speak very quietly.
Yeah, what is that? No, what was that thing?
This method,
Yeah.
this
Yeah.
does the same thing that this does, except it's simpler and cleaner. But it gave me the same answer in both cases. So it still worked out either way. So yeah, we went over this method last class. Or maybe it was the class before. We did it last week. All right, let's try one more. Okay. So this one, having a 0 in there, if you think about it, it's going to be x plus 0, right? X minus 3, x plus 2. But x plus 0 is just x. So every time you see a 0, that just means you're going to have an x out in front. Okay. And now you just need to multiply these two together. Okay. And whichever method you use, it's, x squared minus x minus 6. That's just speeding it up, but I'll show you negative 3, 1, 2, negative 6, 2, negative 3, 1, negative 6, negative 1, 1. So either way, I don't care. If you multiply it out the long way or the short way, it doesn't matter. And now you got to deal with that x. So when you do that, you get x to the third minus x squared minus 6x. Am I making any sense whatsoever? Is everyone at home just like face planting and shaking their head saying, what is going on?
I mean, did you add the negative 3 and 2 or multiply them?
1 second. Okay, can you say that one more time?
Like, did you, for like getting the negative 6, did you multiply negative 3 and 2 or add them?
Multiply.
Oh, okay.
Yeah, everything's multiplied. Yeah, it's this doing this process here is the same way you learned how to multiply when you were a little kid. Like for example, if you had to multiply, 37 times 26, right? You would do 6 times 7 right? And you would get 42. Then you do 6 times 3, which is 18, add 4, which is 12, skip a space, and then 2 times 7 and 2 times 3. And that's exactly the process I do here. 2 times -3, 2 times 1, skip a space, 1 times -3, 1 times 1. And then I add down. So it's the same kind of pattern. It's this multiplication, all right? And then you do this multiplication, and then you do that multiplication, and then you do that one. So 1, 2, skip a space, 3, 4. All right, you try this one. All right, you do those. Use that, please. How are we doing, ladies and gentlemen? Do we have any answers? Any others? So you should be working with x plus 4, x minus 1, and this guy just gives me an x. So I multiply these two out, and I get, well, 1, 4, 1, and negative 1, negative 4, negative 1, 4, and 1, 1, 3, negative 4. So this was these two, and now I got to put in that guy. And so I plug in, I multiply everybody by x, and that increases the exponents by 1. X to the third plus 3x squared minus 4x. All right. How do we feel about all this? Horrible, evil, possible? Scale of 1 to 5. Okay. So if you're not comfortable doing it this way, that's fine. Okay. But I mean, if you need to, and I'll just do one really quickly. If I had 3, negative 4, and 7, okay. If you needed to, you could do it one at a time, okay. X squared plus 4x minus 3x minus 12. And now I got to combine my like terms right here in the middle, and I get x squared plus x minus 12, x minus 7. And now you just got to do it the long way, and that's okay. It still works. Okay. So x to the third minus 7x squared x squared minus 7x minus 12x plus 84. And now you got to combine the like terms. So you can do it the long way. I don't care. It's up to you. Second. I'm trying to answer a question. Okay, so I'm coming back to this one for a second. All right, so I'll do this one the long way. just to show that you can do it. You get x squared minus x plus 4x minus 4. And now we combine the like terms. And now I got to deal with that x. So that x comes in and raises everybody's exponent. Which is the same as that. Does that help? Cool. Cool. All right. All right. So let's talk really quickly about some of the stuff we covered last week, because we got to deal with a graph. All right, so let's do, all right. Let me pick a good one, and I'll do it in Desmo so y'all can see it. Where I don't want to give you one that's really bad. All right, well, let's see if I can do one that's like that. Okay, let's do this. This will be a good one to work on. All right, so we have this polynomial, okay? And you're gonna have to do several different things to it, okay? Second. Nope, that's not the one. All right, so you're gonna have to answer some questions. So this, by looking at the equation, okay, you're able to tell me the, first of all, what is the order of this polynomial? Is it linear? Is it quadratic? What is it? Ah, snap. Dang, I lost that. You guys remember those? This has an order of 4. What do we call polynomials that have an order of 4?
Quartic.
Yeah, quartic. Yeah. So this is a quartic And how many terms does it have? It's got 3. So what do we call that when it's got 3 terms? Guys, copy those down. This is a quartic trinomial. It's quartic because of the x to the 4th. It's a trinomial because it has 3 terms. Okay. All right. Now, let's talk about end behavior. So, looking at this picture, and I'm just going to copy it. So end behavior what happens with these arrows? Okay, that's the deal. And here's how you write your answer. As x approaches negative infinity, f of x approaches, and look at where that arrow is going. So as my ant walks along this thing, okay, and as he's walking towards negative infinity, as he's walking to the left, he's also walking down, right? He's going left and he's going down. And we can tell that by the arrow. So my function is also going to negative infinity because it's negative infinity downward, as well as negative infinity to the left, okay? And then, so that's this end. Now this end, as x approaches positive infinity, so my ant is walking to the left, to the right, over this way. As it walks this way, he's falling downward, isn't he? You see? So that's end behavior. Let's do 1 or 2 more of those, okay? It all depends upon what's happening with your arrowheads, okay? So your arrowheads are either going in 1 or in 4 possible directions, okay? So let's kind of like sum it up. Let me do this. So if you see arrowheads on your function, and an arrowhead is pointing up like that, you would say, as x approaches infinity, f of x approaches infinity. Because it's going positive in the x direction, and it's going positive in the y direction at the same time. It's going both ways. It's going left and up. If you have an arrow that's going down like that, you say as x approaches infinity, because you're going to the right, f of x approaches negative infinity because he's going down. So you're going positive in the x, but you're going negative in the y, headed down that way, okay? If you have an arrowhead that's pointing like this, as x approaches negative infinity, because I'm going to the left, right? F of x approaches positive infinity because he's going up. So he's going left and he's going up at the same time. And finally, here, as x approaches x approaches negative infinity, because I'm going to the left, my function is going down. All right. So these are your four choices. And what you do is you look at your function and you make a decision about where the arrowhead's pointing. Okay. So first of all, has everyone got this guy copied? You're going to need him. Give me a thumbs up when you got this picture copied. Okay. So let me give you a question about it. Okay. I'll just kind of leave this over here in a second and I'll deal with them. All right. So if I gave you a graph that looked like this, okay. So looking at our arrows, this arrow is pointing up and to the left. This arrow is pointing down and to the right. Okay. So my end behavior, you got to write the things for both arrows. Okay. So this arrow pointing in the way that it is says as x approaches negative infinity, because it's going to the left, f of x approaches positive infinity. And with this arrowhead, as x approaches positive infinity, because it's headed towards positive in the x, f of x approaches negative infinity because it's going down. Does this make any sense at all? All right, you want to try one? All right. 1 second. Okay, so I'm going to give you a picture. You're going to write your end behavior in the private chat. If you want the infinity symbol, by the way, the infinity symbol is 2, 2, 1, the letter E, and then you hit Alt X. You want to try and write that in the chat right now, just to show me that you know how to write the infinity sign? Everyone do that real quick. Go into the private chat and type 221E, and then hit Alt X. And if you're on a Mac, that sucks for you because you can't do it. Sorry. So 221E, and then you hit Alt X. And it'll turn into the infinity symbol. There you go. Okay, cool. So here's what I would like you to do. I'm going to give you this picture. And would you write in the chat, it's end behavior. If you want to do the arrow, by the way, if you want to get really fancy with it, the arrow is 27F6 alt X. And that's the arrow. And the infinity sign is again, which you just did, 221E alt X.
What are we doing now?
You're writing the end behavior of this. I'll wait for people to put in some answers.
Oh, yeah, I don't understand.
Okay. Well, we've been working on doing end behavior. And so, did you copy this page down?
Yeah.
So looking at this picture, you're going to pick which one of these or which two of these four, and then you're going to write them in the chat so I can see that you know the end behavior. So looking at that arrow and looking at that arrow, that decides which ones you're going to pick. So this arrow points down and to the left. So you're going to write this. And this arrow points up and to the right, like this arrow. So you're going to write this. These are the two things you need to write down. All right, well, I'll take it. So as x approaches negative infinity, f of x approaches negative infinity, because I'm going to the left and I'm going down, left and down. And over here, as x approaches positive infinity, f of x also approaches positive infinity, because I'm going to the right and I'm going up. All right. How do we feel about end behavior? All right. Okay. Now, the next thing you're going to be asked to do is what is called the maximum number of turns. Okay. So if we look at the graphs of all of the polynomials that we've looked at so far, okay, we had linear, right? We had quadratic. We had cubic. We had quartic. And we had quintic. Now, these were x, x squared, x to the third, x to the fourth, and x to the fifth. All right, so now if we look at the number of times it turns around, okay, think about that ant walking on this guy again, right? If this ant is walking along this line, he's always pointing in the same direction. He doesn't change from going up or down. He's always going the same way. So this has 0 max turns. In a quadratic, he's going down and then he turns around and he goes up. Right? So he turns around one time. On my cubic, he's walking up, then he's walking down, then he's walking up again. So he turned around from, you know, he flipped 2 times. One right here when he stopped going up and what started going down, and then right here when he started going up again. Okay. So we have 2 max turns. In my quartic, he's walking down. Now he's walking up. So that's 1 turnaround. Now he's walking down. That's 2. And now he's walking up again. So there's 3. You see, he turns himself around, up, down, you know, or down, up, okay? 3 max turns. And with the quintic, same kind of idea. I'm going up, I'm going down, I'm going up, I'm going down, I'm going up, right? So he changed directions 1 time, 2 times, 3 times, 4 times. 4 max turns. Now, if we look at this, there's a pattern to this, obviously, right? As I increase my exponent, the number of max turns also increases, okay? And if you look at it, you'll notice that like on the quintic, 5 gives me 4 max turns. 3 exponent gives me 2 max turns. What would, let me ask you this question. See if you can tell me this. How many max turns? Put that one in the chat. How many maximum turns on that polynomial? Put your answer in the chat, please. All right, make sure you copy that down, guys. Yeah, we subtract 1. Okay, look, 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. So here, 18 minus 1 is done. Okay, guys, you don't overthink it. All right, it's just subtract 1. You're done. So let's look at this screen. Looking at that polynomial, how many maximum turns? Oh, keep pushing that button. How many max turns on this polynomial? Right there. Right. Take the maximum exponent, which is 4, and subtract 1. So now, how many max turns on this polynomial?
Two.
No, I'm going to look at my biggest exponent, which is 4,178, and I'm going to subtract 1. So 4,177. Okay. Oops. Let's do this. How many on this polynomial? Well, how many maximum turns there? No, there's only one answer, and it's 5. Okay. I don't care if you've got 600 terms here. You're looking at the highest exponent and only the highest exponent. And the highest exponent is 5, and then I subtract 1. Sorry, the highest exponent is 6, and I subtract 1. So there are 5 possible turning points. Okay, now I don't have 5 turning points in this polynomial, but the maximum number of terms is 5. All right. So now let's take a look at this. All right. So can anyone, if we look at these numbers, can anyone tell me what my zeros are? Great. My zeros are where I cross the axis. So right here is a 0, and it's 1. So my zeros are x equals 1 and x equals 1.839. Okay, those are my 2 points where it crosses the x-axis. That's why it's called a 0, because if you'll notice, the y value is 0 whenever it does that. Okay, so if I were to change this, all right, so looking at these 4 important points, my zeros are where it crosses the axis. Okay. So my zeros are negative 2.19 and 0.855. Those are the 2 zeros. Okay, those are your 2 zeros. Okay. This point right here is my maximum. Okay. So we have a maximum at 3.688. Okay. And oh. All right. Oh, snap. I hate Desmos. So I have zeros here and here. Okay. I have maximums here and there. So my maximums are -2 and 1/2. All right. -2 and 1/2 are my maximums. This is a minimum. So I have a minimum at 0. Okay. So let's try this. So in the chat, please tell me what my zeros are. Okay, good. Remember, zeros are where it crosses the axis. Okay. And it crosses the axis twice, or touches the axis twice. Okay, here and there. Okay, what is the multiplicity of this 0 right here?
Four.
Well, it only, see, it crosses once, right? It goes right through it. We wrote these down the other day, and I actually wrote them again today. Go back to multiplicity for a moment. So if it just crosses through, it has a multiplicity of 1. If it comes and touches and bounces off, it has a multiplicity of 2. Multiplicity of 3s look a lot like, kind of like it comes up and it rides along and it touches and then it goes up. So it does cross it, but it comes up, kisses it gently, and then runs away. Okay. You're not going to worry too much about a multiplicity of 4 or 5, but let's come back and take a look at this graph. So this one goes right through it. This one has a multiplicity of what? Look at those 3 pictures I just drew. And which one does this one look like? It goes right through it. So looking at these 3 pictures that I just drew, and now looking at this point right here at 4, which one of these graphs does this curve look like when it crosses at 4? Does it look like that? I don't think so. Does it come up and gently touch it and then go away? I don't think so. I do think it crosses at one point, though, right here at 4. So at 4, we have a multiplicity of 1. Now let's take a look at the at 0, 0. Okay. At 0, 0, which multiplicity do I have? Does it look like a multiplicity of 1, a multiplicity of 2, or a multiplicity of 3? Thank you, Jovi. That's correct. Thank you, Jonathan. That's correct. And if we look at the equation, if we factored the equation, you'll see that multiplicity. I have a GCD and then x minus 4. So my roots are x equals 0 and x equals 4. And 0 has a multiplicity of 2 because of the 2 exponent. And this has a multiplicity of 1 because, well, there's a 1 exponent here, but we don't see it. But it only shows up one time. Okay. So multiplicity, the graph, the zeros, they all relate to each other. All right. I don't feel good about giving you this quiz tonight. I'll do it tomorrow night, but honest to God, I don't know, because like I'm only getting a few of you answering, and so I really don't know if anybody's ready to take this quiz or not. So I'm going to hold off on the quiz, and I'll give it away tomorrow. All right, everyone have a great day. I will see you tomorrow.
Good day.